Okay, so good morning once again. Today we're going to continue our discussion on machine learning, in particular decision trees. So decision trees is part of supervised learning. It's under classification and regression trees. Okay, now we're going to make use of this file that I shared with you, FFTrees examples. What were the packages that we learned last time? Do you recall? What packages did we use in order to generate a decision tree? Anyone? We used in particular two packages. What were they? What were these packages? One was okay, okay, the party package. Yes, thank you. That's correct. Thank you, Matthew. Thank you, Margot. And the other is the party and the R part. Have I discussed the R part package with you, class? R part package. May I have a confirmation from you, class? Because if not, then this is what I think I'm missing. This is, I think this is the recording that we made in the other section, in the afternoon section, which I might not have shared with you yet. May I know, class, if we, oh, I see. So this one, okay. So this is the part that I haven't, the recording that I haven't shared. Okay. Uh, Matthew, help, please kindly remind me later, maybe this afternoon, to post the video on our part, because this is another this is another package that we can use for a cart for classification and regression trees, which is part of decision trees. Okay, so that's I think so. Because I believe that there's one part that I haven't shared with you, and it's not the party package. It's rather the R part. So I'm going to post that later. Okay, but today we're going to use another package. Okay, thank you. Okay, and that's the fast and frugal trees, the FF trees. So this one, fast and frugal trees. Okay, so let's just quickly take a look at the text that I have already shared here. So as I mentioned a while ago, decision trees is a part of supervised learning. So it's supervised because we have already we know the variables are already named. Okay, and usually we know the output. Unlike in unsupervised learning, which we really don't know the output. Okay, so an example of unsupervised. What's an example of unsupervised learning? Anyone, please? Unsupervised learning, as distinguished from regression and classification trees. That CART, no? Classification and regression trees. Anyone? You can check the internet. An example of a unsupervised learning algorithm. Anyone, please? So that we know the distinction between what supervised learning, machine learning is, and unsupervised machine learning. So waiting for your response, class. What's an example of unsupervised machine learning algorithm? Yes? All right, yes, Nicole, that's correct. No? Nicole, kindly share your answer to everyone. Anyone else? Ang sabi ni Nicole is clustering. Yes, clustering. You have data and you'd like to group those data. Okay, you don't know how to group them. That's clustering. So you can create a model whereby the data that you're using can be clustered into several groups. And what's the use of that? That can be used for marketing purposes. You have this cluster that are common as far as these attributes are concerned. So when you have this clustering, when you have this grouping, you can now target your specific cluster. Let's say a marketing promotion. How do we now promote a particular service or product to this particular cluster. Okay, because nowadays a one ad or one promo gimmick fits all is no longer working. It's no longer practical. So you have to fine tune your, let's say, promotion so that you're targeting a particular segment of the market. And how do you know that particular segment? You can do k-means clustering. You can cluster your data in such a way that you're able to identify what attributes in particular uh, interest these clusters. So that's an example of unsupervised learning. Okay. But the focus of this subject is more on supervised learning. So we have we have done that. We had an example in the past in using the party package. There's another package that I have discussed with the other section, which I'm going to upload also, the RPart package. And now we're going to make use of this, okay, as part of our decision trees. And the next meeting, we're going to random forest, which is actually still part of CART, but it's more powerful. Okay, we're going to combine random forest and cross validation. Okay, so what did I write here? The major advantage of decision trees is that they're very easy to explain. Okay, they closely they closely approximate human decision making compared to other regression and classification approaches. Kasi di ba parang you're just going to create trees out of it. You're going to create uh, subgroupings. So, for example, is the weight of this person like this? If so, then it will belong to this group. Otherwise, it will belong to this other group. So it's it the process, as we say here, closely mirror human decision making processes. Okay, and they can also be displayed graphically, and they can easily handle qualitative, not only quantitative, but also qualitative predictors. Thus, they're able to create what we call dummy variables. Okay, however, there's one caveat to this. Decision trees generally do not have the same level of predictive accuracy as other approaches. Okay, so since they aren't quite robust, a small change in the data can cause a large change in the final estimated tree. So medyo sensitive sila, no? Yung decision trees. Now, enter FFTrees. Okay, so anong kaiba ng FFTrees? Are you familiar with Malcolm Gladwell? Tipping Point, Blink. Have you heard of those bestsellers? Yes, no, please. Si Malcolm Gladwell kasi author yan, di ba? Siya yung author ng Tipping Point, siya yung author ng... Okay, thank you. That's... Maybe I can suggest... Yun nyo lang ha. Let me just show that. Tipping Point. Okay. Right? Okay, this is an interesting book, yung Tipping Point. No? Any business student would... it would be good for a student and a business student to read this. So ito yung tipping point. I don't know if it's maybe you can access this. Ayan, ito yung book, no? The tipping point. Ito si Malcolm Gladwell. He wrote this book. Very interesting yung no? Very interesting yung concept niya ng tipping point. So there comes a point in a phenomena where wala na, hindi na mapipigilan, no? Whatever that phenomena is, you cannot anymore stop that. There's this what we call the snowball effect. And Malcolm Gladwell used several illustrations about this concept of the tipping point. Okay, so meron pa siyang isang book, yung The Blink. I've read both, and I'd likely I would encourage you to read. Yung una muna, Tipping Point, that was the first book. Tapos yung susunod yung Blink niya. Okay? So sabi dito ni Gladwell, there's a common misconception about good decision making. Okay, sabi ni according to what's the usual belief is that in order to have good decision making, kailangan more time, more information, and more effort. Okay, before you can put something to a decision, so that the decision that gets better. Okay, so in terms of decision making, though, the norm is that more is better. Pag mas maraming information, mas maraming time, mas maraming nagagather na insights, it's better. However, that will not always be true. Okay? Okay, of course, may mga instances na doctor making a diagnosis. So, di ba, kaya nga nagkakaroon ng mga more medical tests? Because the assumption is that the more medical tests, the better. Okay? Even in investment, if you can get more data, if you can create a very complex statistical model that best describes the past data perfectly, then you can predict better what will happen in the future. Okay, however, there is many research also that says that this is not necessarily the case. The more is better theory is in many real world situations flat wrong. Okay, sabi ni Dr. Giga Ranzer, sabi niya, less is more for two key reasons. Okay, number one, complex decision models with many parameters may lead to overfitting. Remember what we mentioned a while ago, before, yung overfitting. Okay, when we have too much information, too many attributes, then it can also it tends to capture the noise of that data. So that when we fit that model, when we fit that model into a new data, then it doesn't work anymore. And that's the case of overfitting. Okay, as I stated here, overfitting occurs when a model is very good at describing one past data set. But when you expose it now to new unseen data, it fails. Okay, it fails terribly. Right. For example, economic models. So you have very many variables you'd like to model the past historical data. But when you try to predict the future, it fails terribly. Okay? It's so hard for complex trading algorithms, sabi ni Malkiel, no? To outperform simple index funds in the stock market. That's surprising, no? Kasi we might think, hindi ba dapat mas maganda yung mga very complex na models, very complex algorithm? Pero based on results, very complex models do not outperform yung mga simple models lang. They fail to outperform simple index funds. Okay? And second, aside from the statistical component, statistical reasoning component, is the psychological reason. So, what's that about? Ano yung psychological reason? Okay, we have sa emergency, no? Kunyari sa emergency room. Do you think the doctor will have to run yung data ng individual na yun in order to determine kung operahan ba siya o hindi? Emergency yun. Hindi, di ba? That will not work in emergency cases where doctors or researchers need fast decision. So in those cases, parang hindi yata tama na yung more time is better. More information is better. Okay, so enter si FFT, si Fast and Frugal Trees. Okay, especially if the attributes are just 1 to 5, no? Kung 5 lang, in other words, you have many attributes. If you can ignore the rest, okay, then the FFT model comes in very handy. So the FFTs class, they're non-compensatory. Ano ibig sabihin ng non-compensatory? Ibig sabihin, if you have more attributes, if you have more variables coming in, wala na, hindi na mako-compensate. No? It will become useless. Hindi na siya kailangan to generate a new model. Kasi nga limited, di ba, yung attributes sa ginagamit ng FFT. And they're very simple to use. And they have been used in real-world decision tasks. Kunyari, ito, making coronary artery disease diagnosis. So actual to, actual to class. Ibig sabihin, hindi lang to something theoretical. So si FFT have been used in actual practice to detect depression according to these writers in 2023. So kaya niya makapag-predict and quite a good prediction. Okay? All right, but you might think that limited lang pala yung gamit ni FFTs. Research has shown that FFTs can outpredict more complex models in decidedly non-human simulations. Okay, so we can refer to this article. Okay, so while FFTs have shown promise, there are currently, unfortunately, walang off-the-shelf na mga methods about FFTs. No? So pwede natin gamitin si FF3 package ni R. Okay? So the FFT package gives us this. Makikita natin yung 3 mismo. Okay, we will have standard classification statistics, hit rate, false alarm rate, area under the curve, applied to both training and testing data. So just like before, we're going to split our data into training and testing data. Okay, and there are more robust ways. Yung ginawa natin before was just to split it, di ba, using the sample function, split it into 2. Now there are better ways to do that. Meron tayong tinatawag na bootstrapping, meron tayong tinatawag na cross-validation. So next Friday, we're going to make use of that cross-validation technique. Kasi yung cross-validation technique, it can generate several samples. Using one data set, pwedeng yang ang gagawin niya, mag-create siya ng it can create even thousands of different samples from that data. Okay, in our case, so far, what we have done was to split it into a training data set and to a testing data set. So dadalawa lang yun. But we can generate several samples out of your data set. Okay? So, si FFT, merong dalawang alternative classification algorithms. Merong logistic and merong CART. Okay, anong difference sila? Si logistic regression used if your variable of interest is binary, di ba? To operate or not to operate. Depressed or not depressed. Okay? Binary siya kung dadalawa. And then yung CART natin, yung classification and regression trees, ito yung dependent variable natin is continuous. Okay? So yung FF3, it has a built-in functionality na pwedeng gumamit ng logistic or regression, continuous or pwedeng binary yung dependent variable natin or regression. All right. So I think you haven't installed. So paki-install yung install that packages. Install muna natin si FFTrees. Okay. I will not do that anymore. Kasi I have that already. Okay, I'll let you install that. Or we can use, install nyo lang muna. No? Okay, did it install? Tapos i-library nyo na rin, ha? Please chat if you were not able to install it. Chat yes if you were able to install it, or no if not. Okay, waiting for your chat. No, your answer niya ba yan? No, you were not able to install it. Ay, hindi, sa ano yan eh, sa R part yan eh, kanina. Okay, installed. Thank you, Margot. How about the others? Okay, good. Now, for some time, FFTrees was not yet loaded, was not yet archived in CRAN. No? So when I loaded this, when I installed this several years ago, it was not yet loaded in CRAN. It was not yet archived in CRAN. But now I guess na mukhang na siya, no, na naka-archive na siya sa CRAN. No? Kasi otherwise, class, if a particular package is not archived in CRAN, then you will have to check, pwede natin i-check sa internet kung saan yung repository ng package nito. Because there are other packages, many other packages that have not yet been archived in CRAN, but we can make use of the functionality of that. So we will just have to know where that particular package is archived. All right, that's good. So we have loaded let me just comment this out. So let's require the FFTrees. Okay. All right. Then let's check, kasi may mga data sets dito sa ano, no? May mga check dito sa FFTrees. Now, check nga natin class si BCD extra. Let's check this package. Before we check FFTrees. Okay, so sige, dito na lang, no? Okay, okay, I changed my mind. Let's first take a look at FFTrees muna. Kasi yun ang main ano natin. So FFTrees, or you can, since it's already loaded, we can look it up under the packages section, FFTrees. Okay, here. So it should be already checked because we already loaded this. Generate, visualize, and evaluate fast and frugal decision trees. So let's open this. Let's first take a look at the description file. Okay, so this one. So the title is Generate, Visualize, Evaluate. It's all about decision trees, just like the party package. However, the difference is that it's fast and it's frugal. Frugal means, okay, it's quite stingy with the attributes that it uses. All right. So, who are the authors? Nathaniel Phillips, Neth, Wojcicki, and Wolfgang. So what's this about? What's the general description of this package? Create, visualize, and test FF decision trees, okay, using the algorithms and methods described by Phillips, Neth, etc. FFTs are simple and transparent decision trees for solving binary classification problems. FFTs can be preferable to more complex algorithms because they communicate and are robust against overfitting. So it addresses the question of overfitting. Okay, we said that in machine learning, overfitting is not good. Okay, because it will also model even the noise of your data. So we know that in practice, what we do is to split our data. It can be into three. We have the training data, validation data, and the testing data. And nowadays, we can do cross-validation. We're not only splitting our data into two. We can split it into several sample sizes, into several samples. And that's where the even the bootstrapping and the cross validation, the CV, comes into play, which we're going to discuss on Friday. All right. So let's go back to our packages here, FFTrees. Let's check the. Okay, I want to check the data sets that are found in our package, so we can use this one. Okay, so we can use the VCD extra. Okay, VCD extra, and it has the function data sets here. Class, take a look at this. Okay, so what does this do? The data function is used both to load data sets from the packages and give a display of the names and titles of data sets in one or more package. All right, so we want data sets, and then we identify the package is equal to FFTrees. So we'd like to know what are the data sets that are available in FFTrees. So let's run this. Okay, so the FFTrees package has 17 data sets that come with it. Okay, so we'll be making use of you have this one heart.test, heart.train. We're going to make use of this. Okay, that's all. Heart.test and heart.train. We're going to use the heart.train data set in order to create a model using the training data. And then we're going to test that using the heart.test data set. All right? So the help function, we already did that. Okay, for your documentation, you can refer to this. So the FFTrees package contains two data sets we can use. No? The heart.train, okay, and then the heart.test. Okay, so we can, let's see. I-view muna natin, view C heart.train. All right, so we have several variables here. Age, sex, okay. Let's first take a look at the okay, tingnan natin metadata. So question mark heart dot train. Okay, so this is the heart disease training data. What does it consist of? Contains 150 rows and 14 columns. Let's see heart disease. Ito yung mga variables niya. Age, gender, we have chest pain. Okay, chest pain, it's either in which area, typical angina, atypical, etc. So asymptomatic, so we're not, anyway, we just know that there are 4 categories there. And then this one is resting blood pressure, and then this one is cholesterol, okay, blood fasting, blood sugar, and etc. So there are several variables here in the training data set. Okay, any questions so far? Questions, class? Are we clear so far? All right, good. Okay. On the other hand, let's take a look at the other one, si view naman, si heart, that test. So we're going to use that heart, that test to test how our model using the trained data set works for a data set that it has not yet seen. So these are 153 entries for our heart that test. For our training, it's 150. So in this case, the training data set has even more, the testing data set has more observations to it, which for me is quite unusual. Usually, mas marami yung your training data set will be more than your testing data set. But that's what's given in the package, so okay lang. Okay. So let's go here. All right, we looked at this. This data set contains several variables from several patients. We have the age, the sex, the cholesterol level, and the type of chest pain, which we discussed a while ago. The key variable that we want to predict here is diagnosis. So let's take a look at that first. Heart that trained. Okay, where's the diagnosis? Here. So this one is a diagnosis if the patient, that respondent has heart disease or not. So false, which means no, okay, no heart disease, and then true, which means yes, with heart disease. All right. Okay. So we're going to create a fast and frugal tree, a model. Okay. So let's let's create an object called heart, FFT, alt minus. So let's now predict. We're going to use the function FFTrees. Okay, so before we do that, let's just FFTrees, and here, no? FFTrees. So this is the function. Dilang class, I'll just answer. No? Okay, sorry about that. All right, so we're now creating this object, heart FFT, no? And we're going to make use of this function, yung FFTrees. So let's see FFTrees examples function. Okay, let's dali dapat yung FFTrees lang eh. Purity stat na to, no? Okay, let's go to package here. And then dito lang natin hanapin. Okay, this one, FFTrees, and there. It's the main function to create and apply the fast and frugal trees. So if we click this, okay, the FFTrees function is the workhorse function of the FFTrees package for creating fast and frugal trees. FFTrees are decision algorithms for solving binary classification tasks. They predict the values of a binary criterion variable based on one or multiple predictor variables or Qs. Okay? So this is that function. Ito yung pinaka main workforce nila. And then dito may example pa nga. No? You cannot run that example. Dito sa examples dito, no? You can run these examples. All right? So actually ito yun, ano? Ito, no? Ito yung example natin, but we will do that here. Okay. I just wanted to show you that ang kagandahan class yung sa help function ni R. It's really very very helpful. Okay? All right. So this is actually patterned after this. Okay, pero let's do this on our own. So we're using the FFTrees package. Okay? So ang formula natin is, what's our formula? Ito actually, ano? Our formula is, ano yung ano natin? Ano yung dependent variable natin? We would like to predict itong diagnosis, no? Kasi here you have 153 dito sa train. 150 observations, you have patient 1, patient 2, tapos yung diagnosis nila kung may heart disease ba o wala, no? So we'd like to determine if we can predict this one using some variables here. So yun yung objective nito, no? Can we predict kung may heart disease ba o wala yung isang tao by using some of the predictors here? Right, so let's go back here. Formula is equal to diagnosis. Okay. And how do you write regress in R? I'm aware that some of you have not yet used R for regression. So for regression, you use the tilde. So shift like that. Okay. So this is the how you do regression in R. Tilde. So this is your dependent variable, and then tilde, and then if you want to use all the variables, then you just use dot. So what will this dot do? Ibig sabihin ng dot class, we're going to use all the variables here. Lahat to. Age, sex, chest pain, resting blood pressure, etc. Cholesterol, fasting blood sugar, etc. All right? So this means everything. Let's put a comma here. And then, okay, so this is the main formula, FFTrees, diagnosis regressed on all. Okay, and then, variable being predicted, so dapat dito siya. Let me just, okay, the variable being predicted is diagnosis. No? And then what will be the data that we're going to use? So ang data natin is equal to heart.train. Ba? So yun ang data natin. Heart.train. Right? And then, it already asks from us, what's our testing data? Data is equal to heart.test. Okay. And then let's give it a label. Main is equal to emergency room decisions. Okay. That will be our main label. And let's define our decision label. Decision dot labels is equal to, so, but either dalawa yun, no? Either stable siya or merong let's put it heart attack. May heart attack siya. So let me close the C there, and then let me close the FFTrees. Okay. Check natin. All right. Ang formula natin, diagnosis regress on all our variables, and data is equal to heart.train for our training data, and then testing data natin yung heart.test. And then ang main natin, this is just the label, emergency room decisions, and then yung labels natin either stable or may heart attack. Okay, so let's run this. Okay, error. Saan ako nagka-error? Error in FFTrees. Okay, let's refer to this one. Did I run this already? Okay. Na-load ko na siya, di ba? Error ako . So saan ako nagkaka-error dito? FFTrees. Formula natin, tama naman. Diagnosis regressed on everything. Okay? That's a variable being predicted. And then data is the heart.train. And then, ay, sorry. Hindi ito. Dapat, yeah. Yeah, correct. Thank you, Margo. Yes. Mali yung syntax ko, no? Kasi dito, dapat, yung testing natin to this, yan. Mali ako. To distinguish the training data from the testing data, thank you, Margo, it should be data.test. Okay? All right. So this is your training data, this is your testing data. All right. So I think this will be okay now. Let's run this. All right, that's good. Okay, so you can see that it's running now. All right. Successfully aiming to create a new FFTrees. Okay, then take a look at this. Ito yung mga variables na ginagamit niya, no? And then it's running here some classifications. Successfully created a new FF3 object. And then it continued on. All right. Successfully ranked 13 queues. Okay, so it's writing here the steps that it underwent. And then successfully fitted comparative algorithms. So let's print. Print natin si ano yung object natin? So let's print that. Okay. Let's print it. All right. So we can see here yung output, ano? So tingnan natin. ER decisions, ito yung main title natin, di ba? Made use of FFTrees. There are 7 FFTs, predicting diagnosis. Okay, then you have here outcome cost, high, and then FA, MI, and CR. We'll go back to this. Ano ibig sabihin nito? Tapos ano yung decision rule niya? Okay, tatlo lang. Oh. Only 3 steps. Okay, definition. If thalamoid, so it made use first of the itong unang ginamit niya, no? Ito muna. If okay, sabi niya, if thalamoid is equal to RD or FD. Okay, so if you take a look at this, kung RD siya or FD, okay. Kasi di ba, let's check names ni heart that train thal. There. Okay? Ay, sorry, wala. Ano pala to, no? Ano siya, no? Ano na lang sa summary. Summary ni heart that train ay character siya. No? So binilang lang siya. Hindi natin na-convert as a factor. But anyway, I wanted to see the breakdown. Okay. So let's go here. Let's go back here. So ang decision rule niya, sabi niya, tatlong decisions lang. If thal is equal to either RD or FD, then heart attack yun. And then if CP now, yung chest pain, is not equal to AA, then stable yun. And then if CA is greater than 0, then heart attack. Otherwise, decide stable. So here, it did not make use of all the variables. Ang ginamit lang niya dito, tatlo. Yung thal, yung CP, at saka yung CA. Only 3 variables out of the ilang variables natin? 11. Hindi niya ginamit si age, si gender, chest pain. Ang ginamit lang niya si chest pain, CP, and then itong thal at saka yung CA. So it looked at all of this, and then it decided that it's just going to make use of these 3. Kaya ang tawag niya frugal, no? Frugal, fast and frugal trees, to come up with this decision. All right? We can plot this. Okay, so ito, no? Ito yung misclassification tree natin. All right. So what's this? Yung green dito, this is your correct prediction. No? Okay, decide and true. This is the actual. This is the prediction. So predict niya na ano to, stable, and then tama, stable yung prediction. Predict niya na may heart attack pero stable naman pala siya. So the off diagonals here are wrong. Yung tama dito yung diagonals. So it predicted heart attack, may heart attack talaga, 66 tama. Ang mali niya, it predicted that it's stable. Okay, pero actually hindi siya stable. May heart attack siya. Okay? So you can find here the accuracy. Saan nagaling yung 80%? 80% is 54 plus 66. I-add natin yun. 54 plus 66 divided by total 150. Okay? So that's 0.8, right? 0.8. 80% yung correct na prediction. So there's also this other metrics, may sensitivity, may specificity. Okay, we'll go back to that. Sige, it's almost time. Pero gusto kong, ito class, nung sinamarize lang natin dito, no? So the use 3 Qs lang or features. Yung thal, yung CP, at saka yung CA. Okay, sinamarize lang nito, no? Okay, so we can also plot. I-plot natin yung ano natin. We can plot the yung ano natin, yung model natin. So we can use the plot function dito. Okay. Saan yung sa plot natin? Ito. Lagyan na natin sa ilalim, no? So here, plot natin siya. Okay, plot. So let's plot our object, yung heart underscore FFT, right? And then ang data natin should be yung train data natin, no? All right, let's run this. Okay. Take a look at this. In graphic form. Kanina kasi in text form lang. Ito, graphical na. No? Alright. So ito yung prediction niya na stable. Probability na stable siya is 56%. Probability na may heart attack is 44%. So you can do this by taking a look at ilan ba yung stable dun sa sa train data set natin. Ilan yung stable doon, saka ilan yung may heart attack doon. Okay, so ito yung decision, ito yung prediction na decide na stable siya. Okay, ito yung prediction na may heart attack. Diba? Ito yung truth table natin, di ba? Okay. So nagaling yung 54. 54. Where did this come from, class? Ito yung predict niya na tama, no? Right? So, sa first step, 55. Tapos sa second step, 11. So sorry, this is stable yun, no? Stable pa lang. No? So this is stable and this is heart attack. Okay? So ang predict niya na stable is 66. You can see here 55 plus 11, that's 66. Okay? Out of the total na, ilan ba talaga lahat yung stable? Ang stable lahat, 55 plus 11 plus 8 plus 4. So that's 66 plus 12, that's 78. And we can see here that 66 plus 12, that's 78. Ito yun. Okay? Yung mga stable is 78. Yung mga may heart attack is ilan? 54 plus 18, that's 72. No? Okay? Yung may heart attack. So ito yung breakdown ng predict niya na tama. No? Dito, 47 plus 7 na predict niya na tama na may heart attack. Ito yun, 54. Okay? Ilan yung mali na predict niya na may heart attack? Ang predict niya na may heart attack, ito, plus yung decision, yung prediction, na may heart attack, na hindi naman wala namang heart attack, is 18. So where did that come from? Ito, yung mali, no? 16 plus 2, yung red dito. So that's 18. So yun ang mali niya. No? Okay, mali niya dun sa prediction niya na may heart attack. Ito yung mali niya na prediction sa may stable. 66 yung tama, 55 plus 11, that's 66. And yung wrong niya, 8 plus 4, that's 12. Alright, so you can see here the sensitivity, the accuracy, that's 80%, specificity, etc. And then you have here the receiver operating curve. Didiscuss lang natin next time yan kasi it's almost time, practically time na. All right, so just to end this class, okay. Ito, paano kung sa testing data natin gagamitin? Kasi so far ginamit natin siya sa ano, 'di ba? Sa training data set. Now, will it work, class, kung sa testing data set natin gagamitin, yung data.test, which is the heart.test? So, pwede natin, i-direction natin, plot natin. So, yung model natin is FF underscore, ano yung model natin? Heart pala. Heart underscore Yan, that's our model, di ba? And then let's use it for data is equal to our test data. So what are we doing now? Tingnan natin kung yung model natin works good if we're using a data set that has not been seen by our model. What's our model? Heart FFT. No? And then ipapaplot natin yung result nito kung gagamitin niya sa test data set natin. So let's run this and let's see. Okay, tingnan nyo accuracy niya 82%. So mas mataas pa nga kaysa dun sa sa training data set. Accuracy 82%. Okay? So it tells us that our model worked, no? Despite the fact that rinan natin yung model natin sa isang data set na hindi pa niya nakikita. No? Kasi ang ginamit natin kanina yung training data set. Ito testing data set to, no? You can take a look at the accuracy. All right? So dito ang tamang prediction niya 46 plus 15, right? That's 61. Ito 'yon, no? Predict niya na stable and it turned out to be stable. Correct prediction to. So this is your correct prediction. And ang na-miss niya, nag-predict siya na 70 yung stable pero 61 lang talaga. So 9 yung mali niya dito. Yung predict niya na may heart attack, 64 yung tama, 19 yung mali, no? So that's 81. 83 pala. 83 yung 64 out of 83. Okay, and then tignan niyo to class kung ano yung mga ibig sabihin nito, no? And then this one, as last class, this actually compares yung performance ni FFT, ito siya, yung green. Okay? So isa siya sa top, no? As far as sensitivity is concerned. So this is your FFT. This is your CART. Logistic regression is dito. Okay, random forest in pula. Where's random forest? So in violet. Ito ba yan? Hindi ko masyado makita. And then this is your support vector machines. Alright, so ang ginawa ni FFTrees, no? Kinumpute din niya, nag-model din siya using this other methodologies. Logistic regression, random forest, support vector machines, yung CART class, yung FFT dito. Okay? And it tells us kung ano yung rank niya in terms of ROC, the receiver operating curve. All right. So let me stop there, class. Okay, did it perform well? And lastly, class, sorry ito na lang. Kasi may default tayo, no? You can also create, no? You can also create your own FFTrees. Kunyari, cholesterol greater than 300, then heart attack. Tayo lang nag-ano nito, If age is less than 50, then stable. If slope is either up or flat, predict attack. Otherwise, predict stable. So you can write this. Okay, you can write this prediction. You can write this using FFTrees. Kung meron kang sariling parameters na gagamitin, and then it will generate now yung test na to. Okay. All right. So okay, medyo mahaba ito, no? So sige, ano na lang gagawin ko dito, class? I'll post this video together with the R part, and then I'll post also the code here. Okay, you try it and try to see how this perform. Kasi konti na lang naman, konti na lang naman to. So okay. Ibigay ko na dito kasi baka makalimutan ko, no? Okay, hindi. Not that. Okay, do I have it here? Right, sorry about this, class. Wala dito. Wait. Here, sa files. Wala, hindi ko siya nalagay dito. Okay, anyway, I'll post it. Matthew, paki-remind na lang din ako, So, ipopost ko yung code dito for your reference, and then i-plot, you know how to plot this. And then you can see if this, if your model, if the one that you created performed better than the default, yung generate ni FF3 based on the data that's given. Take note, class, that we gave FFT all the data. No? Lahat yan, lahat ng variables binigay natin kasi tilde then dot. Ibig sabihin, i-regress na sa lahat. But FFTs will automatically just cut, no? Hahanap lang siya ng pinakamagandang combination. And it's usually less than 5 attributes. Okay. All right. So let me just stop recording now.